Hello, champions. Okay, so this is chapter 1, ratio and proportion, indices and logarithms. Unit 4, logarithm revision with you. Okay, so what did we learn in this unit? Suppose a power x is equals to n is given. So how can we write it in the log form? Log n to the base a is equals to x. Okay, and what is anti-log x is equals to n to the base a. Okay, so what are the laws of logarithms? We have learned three laws. Log mn to the base a is equals to log m to the base a plus log n to the base a. Then log m divided by n to the base a is equals to log m to the base a minus log n to the base a. Third law is log m power n to the base a is equals to n into log m to the base a. Change of base, log a to the base b is equals to log a to the base m divided by log b to the base m. Okay, some special logs. Log a to the base a is equals to 1. Log 1 to the base a is equals to 0. How can we transform logs into normal equations? A power 1 is equals to a, and this one a power 0 is equals to 1. So anything raised to 0 is equals to 1. We have seen this in the indices unit. Let's read the text. Change of base, fundamental laws with same base, quotient of two numbers, product of two numbers, definition of log and antilogs. Okay. All right. So one more thing we have learned about how to calculate log x to the base 10 if it is y. Okay. So there was some shortcut tricks, calculator tricks we have seen. What was the tip? Step 1. Press X on your calculator. Step 2. Square root 15 times. Step 3. Minus 1. Step 4. Divide by. Divide by phone number 1. So what is the phone number 1 equals to? 0.000702724. So you can calculate approximate value of log to the base 10 with this method. How will you calculate anti-log? Anti-log to the base a. Anti-log of y is x. So how will you calculate? Step 1. Press y on your calci. Step 2. Exactly opposite. Multiply by phone number 1. Step 3. Add 1. Step 4. Multiply equal to Press 15 times. So what is phone number 1 equals to 0.00070,274. Okay. Again, this is the shortcut calculator trick to calculate anti-log. So if this is phone number 1, what about other logs with other bases? So for different bases, we have change of base properties. Okay. And for another base, E, for the base E that is exponential, we have another formula. So what does log x to the base E is equals to y? Okay. So e power y is equals to x. So again, anti-log will be like this. So how to convert? So suppose e power y. Okay, if you have to calculate what is the value of e power y. Okay, so how to calculate this? That is x. How to calculate x? So we will write step 1 y into phone number 2. Okay, step 2 plus 1. Step 3 multiply equals to 12 times. Okay, so what is this phone number 2? It is 0.00024417206. Okay, so you will be able to calculate the exponential power of this. Okay, so next, how to convert this effective interest into continuous interest, that is log e, okay, of suppose x. Okay, so step 1, square root of this x, press x on your calci. Step 2, square root 12 times. Step 3, minus 1. Step 4, divide by phone number 2. So what is this phone number 2? It is equals to 0.0024417206. Okay, for any other bases apart from 10 or e, it is change of base property. Again, so logarithms, if a power x is equals to n and n is greater than 0, a is greater than 0 and a is not equals to 1. Why? Because 1 power anything will always be 1. Okay, so if that is given, then log n to the base a is equals to x. Let's see these examples. 2 power 4 is equals to 16 means log 16 to the base 2 equals to 4. 10 power 3 is equals to 1000. So log 1000 to the base 10 is equals to 3. 5 power minus 3 is equals to 1 divided by 125. That means log 1 divided by 125 to the base 5 is equals to minus 3. Again, 2 cube is equals to 8. That means log 8 to the base 2 is equals to 3. What do we have? The two equations, a power x is equals to n and x is equals to log n to the base a, are only transformations of each other and should be remembered to change one form of the relation into the other. If the logs are given, you should be able to convert it into normal index form. Okay. Also, we have seen if a power 0 is equals to 1, so log of 1 to the base a is equals to 0. Similarly, a power 1 is equals to a, so log a to the base a is equals to 1. These illustrations are given, so how will you calculate in the exam? Convert this into normal index formula. So we get a power 1/6 is equals to root 2. So a is equals to root 2 raised to 6. So press 2, then square root, right, into equals to 5 times, since first time we have already written. So you will get answer equals to 8. Okay. So this is the way you will solve in the exam by not trying to solve the equations. Okay. Find the logarithm of 5832 to the base again. 5832 to the base 3 root 2. How will you write it as? 3 root 2 to the power x is equals to 5832. So on your calci, you're going to press root 2, that is 2, then square root, then multiply 3, then into equals to until you get 5832 and calculate the number of times you have pressed equal to. You will get the answer as 5 plus 1 the first time, which is equals to 6. Next, the fundamental laws we have seen. The multiplicative product of two numbers is addition of individual logs. There is no need to remember the proofs. Again, the quotient of two numbers is difference of their logs. Okay. The third one was if a number is raised to the power is equal to the index of the power multiplied by the log of the number to the same base. Okay. The quotient formula. Illustration again. Log of 1728 to the base 2 root 3 can be written as 2 root 3 power x is equals to 1728. Again, press 2 root 3 on the calculator by multiplying, and then multiply equals to calculate the equal to until you get 1728 and add 1 for the first time. You get x equals to 6. The second problem over here, again simple, use all the laws of logarithm. What do we get? Log square root of 5, since half will come inside, so square root of 25 is 5 to the base 10 minus, then the 2 will come inside, that is log 3 square is 9 to the base 10 plus log 18 to the base 10. Now the negatives get divided and the positives get multiplied. We have log 5 into 18 divided by 9 to the base 10. Okay, 9 ones are 9 twos are 18, 5 twos are 10. So log 10 to the base 10 is equals to 1. Okay. Next, change of base again. This should be multiplication. Okay. So we have seen log m to the base a is equals to log m to the base b into log b to the base a. This get cancelled and hence it is equals to this. Or you can divide in this form as well. Okay, these laws and change of base property will be helpful to solve the log questions in the exam. Example 1, change the base of log 31 to the base 5 into the common logarithmic base. So we have log 31 to the base a divided by log 5 to the base a. Simple. If no base is given in the question, we can assume it as base 10. And always remember the shortcut calculator trick for base 10. Okay, the phone number 1 technique. Example number 2, again it is a good example. Prove this equation LHS equals to RHS. So what do we have? Let's write it. Log 8 divided by log 3. Okay, now multiply and reverse the denominator. What do we have? Log 9 divided by log 16 into log 4 divided by log 10. So how can we write 4 as 2 square? So 2 outside, right? How can we write 16 as 4 square? 4 square, so 2 outside. How can we write 9 as 3 square? So 2 outside. So 2 gets cancelled. Log 3 gets cancelled. Right? So again log 4 means 2 log 2. This also gets cancelled. So we have log 8 to the base 10. Log 8 means 2 cube to the base 10, which is equals to the cube comes outside. So 3 into log 2 to the base 10. Hence proved. I hope you understood this example. Now these log tables, characteristics and mantissa are not very important, okay, because I have already taught you the shortcut trick that will be enough for solving problems in the exam. You have to anyways find out approximate value of log if at all it is asked, so that you can, since it is an OMR exam, OMR sheet, like multiple choice, so you don't have to find accurate values. Okay, approximate values will help you easily. Okay, so we have seen the relation between indices and logs. Okay, again these examples, same. Log of 64 to the base 2 root 2, transform it into an index form. 2 root 2 power x is equals to 64. Solve this with the help of calculator trick. You will get answer as 4. Example 2. Okay, so if log bc to the base a is equals to x, so we are asked to prove this one. So x plus 1. So x plus 1 is equals to log bc to the base a. 1 can be written as log a to the base a. Similarly, y plus 1 would be log ca to the base b plus log b to the base b. Correct? Similarly, z plus 1 is equals to log ab to the base c plus log c to the base c. Correct? Now let's write the LHS form. What do we have? We have 1 divided by log BC to the base A plus log A to the base A. Okay. Plus 1 divided by log Ca to the base B plus log B to the base B plus 1 divided by log AB to the base C plus log C to the base C. Now these comes in the division form. So log A, log B, log C. Okay. So now when you flip this, you will get log A plus log B plus log C to the divided by log A, B, C. Since addition, that means you can multiply these numbers. So we have A, B, C. So again, this is also addition, we can multiply. What do we get? We get log ABC to the base ABC, which is equals to 1. Hence proved. Okay. Next example number 3. Prove this equation. So we have 1 plus A is log 12 divided by log 24 into log 24 divided by log 36 into log 36 divided by log 48. So let's cancel the common. So we have log 48 divided by log 48 can be written as 1 plus log 12 divided by log 48. Correct? Since we have same base, now we can add the above one. That means this can be multiplied 48 into 12 on your calci. 48 into 12 means 576, which is the square of 24. So log 24 square divided by log 48. Okay. So this can be written as, let's take 2 outside. We have, what did we have? Log 24 square divided by log 48. This can be written as 2 into B. What is B? Log 24 divided by log 36 into, what is C? Log 36 divided by log 48. This is equals to this. So hence proved. Okay. So this is the summary. This last point, if base is understood, base is taken as 10. Thus log 10 will be equals to 1 and log 1 is equals to 0. So log using base 10 is called as common log, and log using base e is called as natural log. E is equals to 2.33 approx, called exponential number. Here we complete our revision for unit 4. Thank you.